Hello, my name is Norain. I will talk about our reaction rate experiment. Reaction rate is the speed at which reactants are converted into products. Chemical reactions is a given fact that rate at which they occur varies by a great deal. Some chemical reactions are nearly instantaneous, while others usually take some time to reach the final equilibrium. The speed with which a reaction takes place is referred to as the rate of a reaction. We can simplify reactance rate as the change in concentration of reactants or product per unit time. There are a few factors that affecting the reaction rate. Firstly, effect of concentration on reaction rate. The rate of reaction increase when the concentration of the reactants increase. The chemical reaction rate is directly proportional to the concentration of reactants. So we know that the rate of reaction increase when the concentration of reactant increase and the rate of reaction decrease when the concentration of reactant decrease. Time plays a major role in changing the concentration of reactants and products. Therefore, even time is a vital factor affecting the reaction rate. Next is the temperature effect. A chemical reaction that takes place at a higher temperature generates more energy than a reaction at a lower temperature. This is because colliding particles will have the required activation energy at high temperature and more successful collisions will take place. There are some reactions that are independent of temperature. Reactions without an activation barrier are examples of chemical reactions that are independent of temperature. Then, catalysts also effect on chemical reaction because catalyst is substance that increase the rate of the reaction without actually participating in the reaction.
Assalamualaikum, my name is Ezzauddin and my student number is TG20068. And now I will cover the methodology of Lab 6. For part 1, we have determined the effect of concentration on the rate of reaction. Here is the flowchart. We start by placing 5 ml of 0.1 m sodium thiosulfate into a flask and put the flask on a piece of white paper which we already draw a cross on it. Then we add 10 ml of 0.1 hydraulic acid into the flask and start the stopwatch. Afterward, we have to stir the flask continuously until the cross is disappear. Note the time to require the cross to disappear. Repeat step 1, 2, 3 with the addition of distilled water to the sodium thiosulfate as instructed in the table 1. For part B, we have determined the effect of temperature and catalysis on the rate of reaction. Here are the flowchart of the experiment. Start by placing 10 ml of oxalic acid solution into the two test tube which has been labeled test tube A1 and A2. Fill the test tube of B1 and B2 with 5 ml of 0.2 m potassium permanganate solution and 10 ml of 2m or 2m of sulfuric acid solution. Afterward, we have to add 5 drops of 5% of magnesite 2 sulfate solution into test tube B2. Boil the test tube of A1 plus B2 and A2 and B2 in a hot water with the preset temperature. Mix the solution in the test tube A1 and B2, the test tube of A1 and A2, and note the time taken for the mixture to become colorless. Repeat experiment repeat the step 1 to 5 for the other temperature in table 2. That's all. Assalamualaikum, my name is Ezzauddin, and now I will cover the result of this experiment. For part 1, the time for the cross to disappear for them to disappear are here. For 5 milliliter, it will disappear in 4.443 seconds, and for 40 milliliter, it will disappear in 52 seconds, and for 30 milliliter, it will disappear in 71 seconds, and for 20 milliliter, it will disappear in 114 seconds. For 10 milliliter, it will disappear in 270 seconds. Now we move on to part B. For part B, we have to take time for the solution to become colorless. Here are without the pot for the without the sulfuric acid. For A1, for it to disappear in 30 Celsius, it will disappear in 121 seconds. For 40 Celsius, it will disappear in 72 seconds. And 50 Celsius, it will disappear in 30 seconds. And here are the solution where we added the sulfuric acid in flask A2 plus B2. In 30 Celsius, we got 18 seconds for it to be colorless, and for 40 Celsius, it will disappear in 12 seconds. In 50 Celsius, it will disappear in 5 seconds. That's all. Thank you for watching.
Calculation and discussion for part A. The table show the result effect of concentration on the rate of reaction. We have calculated the concentration of sodium thiosulfate solution after the dilution and the value of 1/T. 1/T represent as reaction rate. To find the concentration of sodium thiosulfate, we use the dilution equation M1V1 equal to M2V2. M1 is concentration of the concentrated solution, V1 is volume of concentrated solution, M2 is concentration of dilute solution that we have to calculate, and V2 is volume of dilute solution. So we got the concentration of sodium thiosulfate result by using the equation. Then we calculate the value of reaction rate 1/T. T is time for cross the disappears. This graph shows the concentration of sodium thiosulfate and reaction rate. As a concentration of sodium thiosulfate solution increase, the value of 1/T increase. That means the value of reaction rate increase. From the graph, the concentration of sodium thiosulfate solution increase, the rate of reaction also increase.
Is Kartigen, Naidu, Tinakaran, and my ID is TG20055. Today I want to talk about the calculation and discussion in the lab 6 rate calculation. Let's go for the part B in the calculation and discussion. The first question is to calculate the value of 1 per time. So here we have the schedule or the table which consists of the temperature, time taken for the solution to become colorless for the two parts, which is A1 plus B1 and A2 plus B2. The A1 plus B1 is without catalyst, moreover the A2 plus B2 is with catalyst. So we have the results over right hand side. The next is the graph for the relationship between the temperature and the rate of reaction. The blue color one is the A1 plus B1 and the red color one is the A2 plus B2. So the the temperature increased, the rate of the reaction also increased. The relationship between the catalyst and the rate of reactions. Catalyst speed up the reaction. Catalyst will faster the reaction, so it will increase the reaction rate because a catalyst increase the energy of reactant. A catalyst increase the reaction rate by lowering the activation for a reaction. The next is the questions. First one, the equation for the part A and part B. So for the part A is Na2S2O3 plus 2HCl will convert to S plus SO2 plus 2NaCl plus H2O. For the part B, H2SO4 plus KMNO4 plus H2S2O4 will become H20 plus K2SO4 plus SO2 and MnSO4. So what is the function of the catalyst used in part B? To increase the rate of reactions. Give conclusion from the graph that you have plotted. For the part A, the conclusion was the rate of the reaction increase if the concentration of the sodium thiosulfate solution will increase. For the part B, A2 plus B2 has faster rate of reaction than A1 plus B1. That's all for me. Thank you.
Okay, the conclusion of the experiment was to achieve the objective of the lab. To better understand concept of the reaction rate, let's look at the determinant of the effect of concentration on the rate of reaction and effect of the temperature catalyst on the rate of reaction. Firstly, place boiled tube A1, B1, A2 and B2 in hot water with present temperature in table 2 as per model. Mix the solution in the test tube A1 and B1. Note the time taken for the mixer to become colorless and mix the solution in the test tube A2 and B2. Note the time taken for the mixer to become colorless. At the end, repeat step 1, 2 until 5 for the other temperature at the table 2 as been modeled. From all the data we have analyzed above, we will draw the conclusion below. Temperature affect the rate of chemical reaction. The warmer the water is, the faster reaction will be. The colder the water is, the slower the reaction will be. Concentration affects the rate of chemical reaction. The higher the concentration is of the react is, the faster the reaction happens. The lower the concentration of the react is, the slower the reaction happens. Surface area affects the rate of chemical reaction. The largest the surface area of the reaction is, the fastest is the reaction will be. The smaller the surface area of the react is, the slower the reaction will be. Present of the catalytic effect, the rate of chemical reaction.